So this is your 10th class of your subject Kinematics of Machines, and in the previous class we have discussed the degrees of freedom of different objects. You can see the degrees of freedom of a fan is 1, and the degrees of freedom of a rocket is 2, and similarly the degrees of freedom of a vehicle, you can say a car, it is also a 2. And when you consider an aeroplane, the degrees of freedom of an aeroplane is 6. It means you can say that degrees of freedom is nothing but the number of independent motions a body can have. Okay. Otherwise, you can say number of variables which are required to define the or to describe the condition of that particular object. And we have discussed some examples. And maximum a body can have 6 degrees of freedom, 3 linear degrees of freedoms, and 3 rotary degrees of freedom. And we have started with the numericals. We have started with the numericals on degrees of freedom. Yeah, just wait for a second. Just take. We have solved some numerical on a 3-bar chain, you can say, and 4-bar chain, and this 5-bar chain. And after that, we'll continue the problems. Please take this one, the 7th one. Whether this is visible, this 7th one. If it is visible, please copy this figure and try to find the degrees of freedom. Abhishek, whether this figure is visible, the 7th one. Abhishek from A division. Anyone from 4th A division? So this screen is visible.
Yes, sir.
Okay. So in this case, you can take the 7th problem. So it is having 3 kinematic links. First one is this one. You can see the fixed kinematic link. So I can call it as the first link. And this is the second kinematic link. And this is in the form of elliptical shape. This kinematic link is known as the third kinematic link. So number of kinematic links are 3. And what about the number of binary joints? Between first and second, there is one joint. Again, between first and third, there is one more joint. So, and there is no joint between second link and third link. There is only a contact. There is no joint at all. So I can say number of binary joints that is from between 1 and 2, between 1 and 3. So there are 2 binary joints. And you can see in this mechanism, so there is a point contact. The contact between a second link and the third link is in the form of a point. So which is nothing but a higher pair. So h is equal to 1, which means the number of higher pairs is 1. So after inputting all the values, you'll get the degrees of freedom as 1. Whether you're getting the answer, that is n is equal to 1.
Yes, sir.
Okay. Next one, I'll take a simple example. So this one. So double slider mechanism. Double slider mechanism. Just copy this figure. I think this is the 10th problem. Just copy this figure. There is a frame in the shape of a plus mark, as I explained in the double slider mechanism. So it is having a vertical groove and as well as a horizontal groove, which forms a frame, that is a fixed one. Inside that frame, there are 2 sliders, and those 2 sliders are connected by a coupling link. If you want, can take this one. This one. This is nothing but a double slider mechanism. Correct. So the gray color is nothing but the fixed frame, which forms a first link, and these 2 yellow color sliders, they'll form 2 separate links, link 2 and link 3. and the link that connects both the sliders is nothing but the fourth kinematic link. Okay, and you can see there is no point contact between any links, and you can say the two sliders are having a surface contact with this frame, this plus color, this gray color frame. So the both the sliders are having a surface contact. Okay, and you can say number of kinematic links are nothing but 4. L is equal to 4. As I said, first this frame which is fixed, I'll consider as a first link. This slider I'll consider as a second, and this slider as a third kinematic link, and the link that connects both the sliders I'll consider that as the fourth kinematic link. Total number of kinematic links are 4. And joints. What are the number of joints? J is nothing but it is also a binary joint, or you can say it is a lower pair also. Any one. Okay, and you can say there is a joint between this second link and this fourth link. You can see at this point. Between this slider and this connecting link, there is a joint. There is a binary joint. Again, between this slider 3, the link 3 and this link 4, there is one more joint. That is also binary. Okay, two binary joints. Okay, two binary joints plus a number of lower pairs. As I said, there are two surface contacts, that is between this slider and the first link, correct? And between this slider and the first link, there are two surface contacts between the slider and the frame. So 2 plus 2 is 4. Total J is equal to 4. J means it includes both binary joints as well as lower pairs. And since there is no point contact or line contact, so I can say there is no higher pair, hence H is equal to 0. So finally you will get degrees of freedom as 1. N is equal to 1. Whether you are getting this answer, N is equal to 1. Anyone from 4th semester C division? Anyone?
Yes, sir.
Okay, thank you. So in that case, I'll move towards the next one. So better I can take this one. Okay, just copy this 12th problem. This one. Just copy this one, a 12th one. Just take a rough diagram. Can anyone tell that what are the number of kinematic links present in this mechanism? Number of kinematic links.
1.
4, correct. So as I said, the fixed link is considered as only one link. Okay, so this fixed frame is considered as only one link. I'll write 1, 1, 1, 1. And to this first link, there is one more link that is attached. That is link AB. So I can call it as a second link. Again at point C, again to the first link itself, there is one more link is attached. That is AC. Again to the same first link, there is a frame. There is one more link, that is AD. The fixed link is considered as only one link, and the remaining 3 are considered as second link, third link, and fourth link. So L is 4. L is 4. Okay. And what about number of binary joints? J is equal to. J is equal to. Just take a note. Just take a note. If there are two kinematic links are joining at a single point, for example, first link and second link are joining at point B. So this point B is considered as a binary joint. Okay. Here also you can see at point C, a kinematic link first and kinematic link third one. They are joining at the same point. Only two kinematic links are joining at point C. So this is also binary joint. And again at point D also, there are two kinematic links. That is first one and the fourth one. So this is also a binary joint. Binary joint means if only two kinematic links are joining at a single point, that point is considered as a binary. But as in case of point A, you can see in this point A, there are three kinematic links are joining at a single point. So I can call this point A as a ternary joint. Ternary means three kinematic links are joining at a single point. Remember, ternary joint. But as the definition says, J means binary joints. Okay, I want total number of binary joints. So first what I will do, I'll count the binary joints. That is, this is a one binary joint, this is one more, this is one more. Because in all these three cases, only two kinematic links are joining at a single point. So at point B, C, D, there are three binary joints. But as in case of point A, so there are three kinematic links are joining. So I can consider this as a ternary joint. And just take a note. So one ternary joint is equal to two binary joints. Write down. So one ternary joint is equal to two binary joints. So how many ternary joints are there? Only one. So 1 into 2. So you'll get total two binary joints. Okay, because I have one ternary joint. As I given in the note, one ternary joint means two binary. Just multiply by 2, you'll get 2. Total number of joints are 5. Total number of joints present in this mechanism. Just wait for a second. So total number of joints are 5. And there's no point contact. Okay, h is equal to 0. Means the number of higher pairs are 0. So whether you're getting n is equal to minus 1. Okay, as I said, as I given in the note, if the number of degrees is less than 0, if it is in terms of minus, you can say it is a statically indeterminate structure. It means by using this formula, we cannot calculate the degrees of freedom of this mechanism if it is less than minus 1. In the conclusion, you can write, so the given mechanism is statically indeterminate structure. As I given the note, please go through the notes which is mentioned in the note.
Sir, how J is 5, sir?
Okay, you're asking J is 5, no? So as I given in the definition, J means number of binary joints, correct? Okay. So can you see at point B, at point C and point D, there are three binary joints. Binary joints means at that point there will be two kinematic links are joining. First link and second link. First link, third link. First link, fourth link. So you can see at point B, C, D, there are three binary joints. So this is visible. This one.
Yes, sir, visible.
Okay. And what about point A? This point A. You can see there are three kinematic links are joining. Second one,
Three joints, sir.
third one, fourth. It means this is not a binary. This is a ternary joint. So one ternary joint at A, at point A. So just take a note. I want J means total binary, but it considers both binary and ternary. It means you need to convert this ternary joint into binary. Just take a note. One ternary joint is equal to two binary joints. Just multiply by 2. So 1 into 2 you'll get 2. Is that clear? Total is 5. Total is 5.
Okay, sir.
Okay.
Yes, sir.
I'll take one more example. A similar example. It's having a ternary joints. Just wait for a second. Yeah, just take this figure, this 18th problem. Yeah. Just copy this figure. So this is a piston or the slider. And this is a fixed frame, this also fixed frame, this also a fixed frame or the cylinder. Okay, so after drawing this figure, so I'll consider all the fixed links as one. You can see this is the first link, this is also first, it's a first. Means all fixed link are considered as only one link. Okay. Then you can see to this first link there is one more link is attached. So that is the second one. Okay. And again this is the third one. So this is fourth, this is fifth, and this slider is the sixth link. Okay. There are 6 kinematic links. L is 6. L is 6. So can anyone tell that how many binary joints are there?
6.
Try once again.
5, sir.
Correct. So just wait, I'll explain how it is. Okay. So there are 5 binary joints. So how it is? So I'll start from this. Between first link and second link there is one joint, one binary. Between second and 3 there is one binary. Again between first and fourth there is one more binary. Then between fifth and sixth there is one more binary. Correct. So 4 binary joints plus one sliding pair between first and sixth. There is this also I'll consider in J itself, in binary itself. Okay. So in binary joints, the J itself, 4 binary joints and one sliding pair. 4 plus 1 is 5 total. And you can see at this point 4. At this point 4 here can see. So this is whether it's a binary or a ternary joint at this point.
Ternary joint.
Okay, because kinematic link 3, kinematic link 4 and 5 are joining at the same point. As I said, if there are 3 links are joining at the same point, so that joint is considered as a ternary. So you can see one ternary joint. Just convert one ternary into binary. As I given the note, one ternary joints means 2 binary. 1 into 2 will get 2. Okay. So this includes both binary joints as well as number of lower pairs. Just remember. So this includes both binary joints as well as number of lower pairs. So there are 4 binary joints and one sliding pair or a lower pair, one lower pair. The lower pair also comes here itself. So 5 plus 2, 7. Since there is no point contact between any kinematic links, H is 0. H is 0. Is 0. Okay. So that we're getting N as 1, degrees of freedom as 1. Just input the values of L, J and H. So you'll get this answer. Anyone? Okay. Thank you.
Yes, sir.
Then just take this link. Just take a rough diagram. So this is a simple. This is the first link which is fixed. Okay. You can consider this as a cylinder or a frame. So I'll write 1. Okay. To this cylinder or the fixed link, there is a piston is attached. The piston is sliding inside with respect to this first link. Okay. You can see at this point there is a surface contact or lower pair. Between the piston and this frame, there is a surface contact. So which comes under the J itself. Okay. And this piston is attached to the third kinematic link. So this is a single kinematic link. It is not a separate. This is not separate. This is not separate. It is a single kinematic link. Okay. At this point, there is one more kinematic link. So I can call it as a fourth one. It is also a single kinematic link. Then this is 5. So this is 6, 7th, 8th, 9th, 10th, 11, and 12. Okay. Including this lower pair. Sorry. I'm discussing this L. No, L is 12. Total kinematic links 12. So total number of links is 12. Any doubts in the kinematic links? You're getting 12? Just take a minute and just get the degrees of freedom.
Explain once again that binary joint.
Okay, and you can see there are 16 binary joints, including the lower pair also. Okay, 15 binary joints and plus one lower pair. And how it is, you can say, I'll start from this first link. Okay, between first and 4 there is one link. So better I'll highlight. Okay, so this is first binary joint. Between
Sir,
Yes, sir.
sir, explain this
one
more.
okay, so you want number of links, that is 12. Total number of links. Just wait for a second. Okay. So first I'll count number of kinematic links. This is the first one. There is a fixed one. That is the first one. Okay. So I've written 1. And this piston is the second link. To this piston there is one more kinematic link is attached. It is a single kinematic link. So that is third. Okay, this is the second. And at the bottom portion of this fixed link, so this is the first link, correct? To this fixed link, there is one more link is attached. So you can see at this point. So this is the fourth. Okay, this is the third one, this is the fourth. To this fourth link, there is one more link is attached. So this is a single one. Fifth. Again to this kinematic link, that is the third kinematic link, there is one more link is attached. This is the sixth. Okay. This is the 7th, 8th, 9th, 10th, 11, and 12. Total number of kinematic links are 12. And I'll go to the joints. I'll go to the joints. Before that, I'll erase this. Yeah. So I want the total number of binary joints as well as the number of lower pairs. Okay. So I'll start from this first link. You can see this is the first link. I've written here first. Between first and fourth, there is one joint. Correct. And between second and third, because the piston is attached to this kinematic link, so here also there is a joint. And this the third link and the fourth link, they are attached at this point like a scissor. Okay. And this is a fourth and fifth at this point. And this is the third link and this is the sixth link at this point. Again 5 and 6. Sorry, this 5 and 6 at this point. So here also one more. Just count how many binary joints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
15, sir, 15.
Correct. 15 binary joints. Okay, 15 binary joints. Okay. And also you can see the type of contact between this piston and the first link. It is a surface contact. It comes under lower pair. So as I said, J means it is a summation of both binary joints. That is 15 plus number of lower pairs. 15 plus 1. Just remember, J means it includes both binary joints as well as lower pairs. Okay. And you can see there is no a circular object. Okay. And there is no a point contact or line contact. Okay. It means there is no higher pair, H is 0. You just input the values n is equal to 1. n is equal to 1.
Sir,
Yeah. Is there any doubt?
sir, screen is not visible.
Okay, just wait for a second.
Sir, screen नहीं दिख रहा.
Yeah, just wait for a second. I think for fourth B and C it is not visible. For fourth A it is visible. Just wait for a second. Yeah. We are discussing about total number of binary joints, that is 16, which includes both binary joints as well as number of lower page. So you can see total 15 binary joints and one lower page, that is surface contact between the first link and the second link. Total 16. Since there is no point contact between any link, so I can say that there is no higher pair. It means H is 0. So finally you can say that the degrees of freedom of this mechanism is 1. Okay, and just take the next one. Yeah, so please note down this, that is a binary link. What is a binary link? You can consider this is a binary link. So how can we define this binary link? A link having connections at 2 points. So you can consider this as a binary link. It means, so I can connect two more links at this point and this point. Okay, so it means this link can have two more connections with two more links. Okay, so I can call this as a binary link. And what about this Turner link? So you can consider this as a Turner link or a triangular plate. So this is having three connections. It can have three more connections with other kinematic links. So at this point and at this point and at this point, it can have three more connections. Hence, I can call this as a ternary link. So which is similar to a triangular plate. And one more is this one, that is a quaternary link. It means this link can have four more connections at this point, at this point, at this point, at this point. I can call this as a quaternary link, similar to a trapezium plate, you can say, or a rectangular plate, a square plate. So this link can have four more connections. So I can call this as a quaternary link. So far we have discussed this one, binary link, a link that can have two connections. One is at left side, one more at the right side. So this is about a binary link and ternary link, and one more quaternary. So we'll solve one problem on this ternary link, similar to this one. If a mechanism is having this ternary link, how to solve this? So please take this figure, and you can see. So the fixed link is considered as one link. This is one. This is also one. This is also one. Correct. And the remaining links, that is this link is attached to the first link at this point. So this is a second link, third, and this is the fourth. As I said, it is similar to a triangular plate, and I can call this as a ternary link. This is only a single link. This is not a separate. This is not separate. This is not separate. This is also not separate. So this forms a single kinematic link. That is you can say a Turner link. So I can give the name as 4. And this one is the fifth one, and this is a sixth. The total number of links are 6. It means 5 binary links and 1 ternary link. And what about number of joints? Okay, number of binary joints. So you can see between first and second there is one joint. Between second and third, one more. Between third and fourth, one more. Again between 1 and 4 there is one more. Between 4 and 5, one more. Between 5 and 6, between 6 and 1. Just count how many binary joints. 1, 2, 3, 4, 5, 6, 7. There are 7 binary joints. And since there is no point or line contact, number of higher pairs are 0, h is 0. So after inputting the value of L as 6, J as this 7 and H as 0, I'll get the degrees of freedom as 1. Okay. Similarly, you can solve remaining problems. You can take this as assignment, and wherever you can see the hatched portion, that will be considered as a one link. Okay, in this case, it is a Turner link. It will be considered as a fourth link. It is also considered as first link. So these are also example of ternary links. So here you can see this is also an example of a quaternary link, because so this link can have 4 connections at point E, point D, point B, and point A. So there's only one link. I can call it as 7. Okay. You can solve these problems and you can take this as an assignment. And one more topic I want to discuss is this one. That is types of constrained motion. Types of constrained motion. So please take the heading as constrained motions are the types of constrained motion. First one is this one, that is a completely constrained motion. Second one is incompletely constrained motion. And last one is successfully constrained motion. The first I'll start with this one. What is a completely constrained? Just consider a cube which is having a square hole, okay, and in that square hole there is a square shaft. The shaft which is having a square cross section, it is going to slide. And as I said in the first class, it forms a sliding pair, and so this is one link and this is one more link. Okay, the cube is one link and this shaft is one more link. And you can see that the shaft can only slide with respect to this cube. It cannot rotate because the cross section is in the form of a square. It can have only a sliding motion. It means this link is it means the shaft is restricted to only slide. It cannot rotate. It means it is constrained. It is constrained to only one path. So I can call it as a completely constrained motion. Since the shaft is restricted to only one direction, it can have only a sliding motion, not the rotary path. So I can call it as a completely constrained motion. And just consider the second one. Again, there is a cube and it is having a circular hole. Instead of a square hole, there is a circular hole, and inside that circular hole there is a shaft, and the cross section area, the cross section of this shaft is in the form of circle. Okay, in this case you can see the shaft can slide front and back, and it can also rotate. Since the cross section area is in the form of a circle, the shaft can have two motions. One is a sliding motion with respect to this cube, and one more a rotary motion with respect to the same cube. It means the shaft is not restricted to only slide. It is not restricted to only a rotary motion. It has a combination of both. It means the restriction is limited. It is not a complete, you can say. Okay, it is not a completely constrained motion. It is not restricted to only one path. So it means the restriction is incomplete. So I can call this kind of motion as a incompletely constrained motion. Okay, since it is having both a sliding as well as a rotary path, rotary motion, the restriction is incomplete, so it can be called as a incompletely constrained motion. Then one more, then how to convert this incompletely constrained motion to a completely constrained motion? So what I will do at this point, you can see here, I'll provide a stopper or collar, you can see, so that what I can avoid the linear motion, the sliding motion. After providing a stopper to this shaft, so there will not be any linear motion along the axis. Okay, it can have a rotary path, rotary motion, but it cannot have a linear motion. It means I have converted this incompletely constrained motion to the completely constrained motion by applying some certain force, or you can say certain a stopper. Okay, so I can call this mechanism or this motion as a successfully constrained motion. Okay, it means the method, or you can say the converting an incompletely constrained motion to a completely constrained motion by using some external force or some external kinematic links, so that the path is restricted to only one direction, either a sliding or a rotary. But in this case, after providing a stopper, the shaft can only rotate, it cannot slide. It means the restriction is to only rotate. Hence, this method of converting an incompletely constrained motion, okay, to a completely constrained motion is known as successfully constrained motion. So you can take this one. Just take a block diagram of this one. What is a successfully constrained motion? So the method of or the conversion of an incompletely constrained motion to a completely constrained motion by applying some force or by using some external mechanical elements. So I can call it as a successfully constrained motion. Okay. So first we have discussed the completely constrained motion, then incompletely constrained motion, and how to convert this incomplete to complete by using a stopper. So this is known as successfully constrained motion. Okay. So this completes your first module, that is a unit 1 of the first module. In the tomorrow's class or in the next class, we'll start with the last module, that is a gate rings. Okay. If there is no doubt, so I'll wind up today's class. Okay. Thank you.